Now let's discuss how to find the inverse of a function. How to find the expression for the inverse of a function. To do that, we just follow the following steps. So you're given the equation for the function f. Now, to get the inverse, what you would do is first, you replace your f of x with y in the equation for f of x. Now that you have an equation in terms of x and y, then you interchange x and y. That means you replace x by y and y by x. Then you solve for y. Now, if this equation does not define y as a function of x, the function f does not have an inverse function, and this procedure ends. Now, if this equation does define y as a function of x, then f has an inverse function, and then what you would do is you replace the y in step 3 by this notation here, by f inverse of x. And if you want to verify, you can verify your result by showing that f of f inverse of x is equal to x and f inverse of f of x is equal to x. Now, the verification is not necessary in the solution, but you can do this on your own. You can do this in your scratch paper if you just want to verify if your answer is correct. The function given here is a one-to-one function. We are to look for the equation for the inverse of the function f, and then we state the domain and range of this function and state the domain and range of f inverse of x. Now, before we proceed, let me just make a comment on the domain and range of the function. Now, if the function is one-to-one, we know that its inverse exists. Then how can we connect the domain and range of the function and its inverse? So one of the property for inverses function is that the domain of f, the domain of the function f, will now become the range of the inverse function. And the range of the function f is the domain of the inverse. Okay, and we can verify that actually from the example here. Okay, so first, let's find the inverse of the given function here. For the first step, first you write down f of x equal to 3 over x plus 5. Now, first, you replace this f of x here by y. So you write that as y equal to 3 over x plus 5. Then, you interchange x and y. So the y here will become x, and the x here becomes y. Then, you solve for y. To solve for y, you can multiply both sides of your equation by y plus 5. That cancels. So you have y plus 5 times x equal to 3 on the right-hand side of the equation. Now, our goal here is to be able to solve for y. So this is already factored. So we will just go ahead and divide both sides of the equation by x, because we want to isolate y. We want to solve for y. So from this equation here, we can divide both sides by x. There. And then you only have y plus 5 on the left-hand side of your equation. And then in that case, if you have y plus 5 equal to 3 over x, then you can solve for y. You can subtract 5 on both sides. So y is now equal to 3 over x minus 5. Now the expression here is the inverse. All you need to do is replace the y here by f inverse of x. So you have 3 over x minus 5. That is the inverse function. Now for letter B, we want to state the domain and range of the function. This was our function. Our domain here, the domain of f. If you recall, to get the domain, we don't want the denominator equal to 0, so we exclude the value of x that makes our denominator equal to 0 from the set of all real numbers. Now the value of x that will make this equal to 0 is negative 5, so we exclude negative 5. So therefore the domain of f, the function f, is negative infinity to negative 5 union negative 5 to positive infinity. Now for your range, actually it's hard to find the range because we don't have like a straight algebraic approach to do that. You can graph this function to see what the range is, but here's the shortcut. You can do your letter C. It's easy to find the domain. So what you would do is just find the domain of the inverse. So see, you can find the domain of the inverse. So this is the inverse function. What's the domain? When will this be undefined? That is when x is equal to 0. So that is from negative infinity to 0, union 0 to positive infinity. Now, because you know the domain of the inverse, you can then state the range of f. The range of f is the domain of f inverse. So that is just negative infinity to 0, union 0 to positive infinity. And similarly, to get the range of f inverse, you use the domain of f. So you use this. So we have negative infinity to negative 5 union negative 5 to positive infinity. Example number 2. We are given a one-to-one function. Our task is to find the inverse of the function, and then we state the domain and range for both f and f inverse. So to find the equation for the inverse function, we first replace this f of x here by y. So we would write y equal to 1 over x plus 3. And then next is to interchange this x and y. Replace the y here by x. And then you replace the x here by y. Plus 3. Then you solve for y. So to solve for y, we can first subtract 3 on both sides of the equation. So x minus 3 is equal to 1 over y. And then y here is equal to 1 over x minus 3. So then, now that we're able to solve for y, you just replace it by f inverse of x. And that is 1 over x minus 3. So this is the inverse function. Now, let's state the domain. Let's state the domain of f. The domain of f, you go and look at this. We know that we will just exclude the value of x that will make this equal to 0. And that is 0. So we have negative infinity to 0, union 0 to positive infinity. Now, to get the range, we'll have to first get the domain of the inverse. So domain of the inverse function here, that's the inverse function, is equal to negative infinity. So the value of x that will just make this undefined is x equals 3. So that means the domain is negative infinity to 3 union 3 to positive infinity. That's the domain of the inverse. And we know that the domain of the inverse is actually the range of the function. So the range of the function is negative infinity to 3 union 3 to positive infinity. And the range for the inverse is equal to the domain of the function, negative infinity to 0 union 0 to positive infinity. Now for the next function here, we have x squared plus 1, and x squared plus 1 is not one-to-one in itself, but if you restrict it, say at x greater than or equal to 0, this expression is one-to-one over this domain here. So the restriction becomes the domain of the function. So let's just write that down first. The domain of f, because there is restriction, is going to be the restriction, and that is from 0 to positive infinity. Okay, now let's go ahead and look for the inverse of the function here. You begin by replacing f of x by y. So you have y equal to x squared plus 1. And then you solve for, and then you replace x by y. So after you replace f of x here by y, the y here will be x and the x here will be y. So you have x equal to y squared plus 1. Next is to solve for y. From the equation here, you solve for y. So you do that by transposing 1 to the other side of the equation. So you have x minus 1 equal to y squared. Or you could write this as y squared equal to x minus 1. Then y here is equal to plus or minus the square root of x minus 1. So plus or minus the square root of x minus 1. Now, we can look at the restriction. In the restriction, that's the domain of f, we know that that is the range of f inverse. The domain of the function, again, the domain of the function is equal to the range of the f inverse. And the range of f is equal to the domain of f inverse. So now the range of f inverse will just be this. That is 0 to positive infinity. And that helps us decide which of the two here is the inverse function. Now the range is positive. So that means we're going to consider the positive square root. So that means we have f inverse of x, because you're going to replace the y here by f inverse of x. And that is just equal to the positive square root. So that is square root of x minus 1. Okay, then we get the domain. So let's get the domain of f inverse. For the domain of f inverse, we recall that since this is a square root function, this would only be defined when x minus 1, the expression inside the square root, is greater than or equal to 0. And then you solve for this inequality here. So that is x greater than or equal to 1. X is greater than or equal to 1 on the interval 1 to positive infinity. Now for the range the range of f, you just take the domain of f inverse. So that means this is just 1 to positive infinity. Now another example. You're given here a function that is 1 to 1. We are going to find the equation for the inverse and state the domain and range of both f and f inverse. First step is to replace this f of x here by y. So you have y equal to cube root of x plus 4. Then you replace y here by x and x here by y. So you have x equal to cube root of y plus 4. Then you solve for y. So to solve for y, you cube both sides of the equation. So you have x cubed equal to y plus 4. So this means that x cubed minus 4 is equal to y. Or you could write that as y equal to x cubed minus 4. Then you replace your y here by f inverse of x. So f inverse of x is x cubed minus 4. That's the equation for the inverse. Now let's go ahead and identify the domain. The domain of f. The domain of the function f. Look at this. When will this be undefined? Since this is 3, the index is odd, then you have nothing to worry about. This will be defined everywhere. And the range, again, we need the domain of the f inverse. So the domain, so let's get first the domain of the inverse. The domain of the f inverse, the domain of the inverse, this is a polynomial expression, will just be the set of all real numbers. This is defined everywhere. So that means that this is also defined everywhere. The range of the function f is negative infinity to infinity. Now, the range of the inverse function will be the domain of f, and that's negative infinity to positive infinity.